Hey my dear friends, today we are going to discuss about our well-known compound of our organic chemistry, that is benzene. Clear? Now benzene is our well-known organic compound. Now it will play a very crucial role in our entire organic chemistry. Majority of the part of our organic chemistry is only of this benzene. Many of the students, they will make the mistake without knowing the properties of the which one, benzene. Now in this benzene, how the sigma bond and how the pi bond, then when it will play very crucial role in the mesomeric effect, in the delocalization, right? Now whatever the misconception you are having about the benzene, now that I was going to clear in this video. Now let's start our. Now why we are going to study the benzene, how the sigma bond and the pi bond is formed, where this application we are going to use in our entire chemistry. Now you see many of the students, they are going to see first well-known compound for you, that is a phenol. Okay, now in this phenol we know that this oxygen, it is having the lone pair of electron. Due to the presence of this lone pair of electrons, it will show the plus m effect. Clear? And as well as it will show the minus I effect. Clear? But majority of the cases the plus m effect is more dominating than the minus I. Sir, why only the plus m effect is more dominating and why not the minus I? Many of the students, they will get confusion. For this concept, why only the plus m effect is more dominating, why not the minus I will clear in this lecture with the which one, with our molecular model. Okay, now next topic we are going to see here. When I take the benzene and your well-known example, that is aniline. Now if the aniline, if it is attached, then why it is increasing the electron density, why it is decreasing the electron density or increasing the electron density at ortho and para positions, that also I will explain very clearly. Sir, you may get a doubt. Sir, this due to the what, nitrogen lone pair, when it is giving its electron density to the benzene, its electron density is increasing. That only why the nitrogen, it is giving its electrons to the benzene with the molecular model, I will explain very clearly. Now listen to the class from the starting onwards. If you skip, now whatever the concept, whatever the application part of the benzene I was explaining, that you will miss. Clear? Now let's start our lecture. Before going to start the lecture and that application, first how the benzene sigma bond and the pi bonds are forming, now we'll see. Now in this benzene, each carbon hybridization is what? sp2. Each carbon hybridization is a sp2. Done. This each carbon hybridization is a sp2, right? Now in the sp2, we know carbon excited state electronic configuration. Normally, sorry, with ground state I will go. With the ground state electronic configuration, we know 2s2 and 2p2. This is the ground state electronic configuration of carbon. Then excited state electronic configuration of the carbon. Excited state electronic configuration of the carbon will be 2s1 2p3. Now in the benzene, each carbon hybridization is a sp2, right? In the sp2, how many atomic orbitals will be intermixed? Only one s and one s and two atomic orbitals will be intermixed. Clear? Now hybridized orbitals, atomic orbitals overlaps leads to give the hybridized orbital. Now this hybridized orbitals will be in this manner. Now each hybridized orbital we are having one electron. Now you see here we are having the pure p orbital. We are having the pure p orbital. This is a pure p orbital. Now already in the hybridization of how the sigma bond and the pi bond it has formed, in that I explained very clearly about the how this pure p orbital is perpendicular to the hybridized orbital. Now this pure p orbital is perpendicular to this hybridized orbitals. This hybridized orbitals. Okay? Done? Now this hybridized orbitals and the pure p orbital which has not participated in the hybridization, that is perpendicular to the which one? Hybridized orbital. Next very key point you have to remember, hybridized orbital always overlaps leads to give sigma bond. This is very, very important. Clear? Now, how many hybridized orbitals we have seen? How many hybridized orbitals we have seen? These 3 hybridized orbitals we have seen, right? These 3 hybridized orbitals should arrange themselves in such a way that it should be free from the repulsions, right? Then when they have arranged themselves, now here one carbon, now this is another carbon. Clear? Each carbon we are having the 1 electron. Clear? Now here this is another carbon. Now another carbon, it will form the bond. Now here we are having the another, here it is having. Clear? Now here one electron, and it will form the bond with the hydrogen. The same pattern it will be repeat. And it will form the in this manner. Here one carbon, one sigma bond. Here one carbon and carbon, one sigma bond. And here one carbon and the hydrogen, one sigma bond. Clear? Now here one carbon and hydrogen, one sigma bond. And here one carbon and hydrogen, one sigma bond. Clear? Here one carbon and hydrogen, one sigma bond. And here one carbon and hydrogen, one sigma bond. And here one carbon and hydrogen, one sigma. Clear? Now in this manner, all the 3 new hybridized orbitals will form the sigma bond. Then we see how the pi bond will be formed. Now you see what I said, each carbon we are having the one pure p orbital, right? That pure p orbital will be which one? Perpendicular to these hybridized orbitals in this manner. Perpendicular to the hybridized orbitals in this manner. Now this sideways overlaps leads to give which bond? Pi bond. Now we'll see with the molecular model how these pi bonds are forming. How these sigma bonds are forming, how these pi bonds are forming. Now we'll see. Now here, now this is our molecular model of the benzene, right? Here in the molecular model of the benzene, here this is one carbon, this is one sigma bond, and this one is a which one? Pi bond. Clear? One sigma, this is also one sigma, and this is pi bond. Now already I explained you very clearly what here these 3 are the hybridized orbitals formed the sigma bond. Here 1, 2, 3. These are the hybridized orbitals formed the sigma bond. And pure p orbital is perpendicular to the hybridized orbitals. I explained you, right? Now you can see. In this manner you can see, I hope. Here this is one sigma, and this is one sigma. Or else if you go it for this carbon, this is one sigma, and this is one sigma, and this is a pure p orbital. This pure p orbital is perpendicular to these hybridized orbitals. I hope it is clear for you. You can see in this manner also. If not, you can see. Done? You can see in this manner also. This pure p orbital is perpendicular to these hybridized orbitals. So now in the sp2 hybridized carbon, whatever the pure p orbital is always perpendicular to the which one? Perpendicular to the hybridized orbitals. Done? Now in this sideways, this carbon is also have the one pure p orbital. Clear? That it will be overlaps in this manner, leads to give the pi bond. That's the reason in this benzene, one carbon it will contain one sigma, and one carbon sigma, and one carbon sigma, and one pi bond. Clear? Here also this carbon sigma, and here one sigma, and here it is a one pi. Here sigma, and here one sigma, and it is a pi. Clear? This pi bond is formed by the overlapping of which one? Now we'll see here. Here in the benzene, whatever the benzene structure we have studied, in this benzene structure, Now in this benzene structure, here how many carbon sigma carbon? How many carbon sigma carbon we are having? Here carbon sigma carbon, 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 carbon sigma carbon. Total 6 carbon sigma carbon we are having, right? This is formed by the overlapping of sp2 and sp2, sp2 and sp2. Next, carbon and hydrogen sigma bond, carbon and the hydrogen sigma bond is formed by the overlapping of which one? sp2 and S, sp2 and S. Next, 3 carbon carbon pi bond, 3 carbon carbon pi bond is formed by the pure p orbital and the pure p orbital. Clear? Now pure p orbital, again once again I am saying pure p orbital is perpendicular to the sigma bonds. Pure p orbital is perpendicular to the sigma bond. For this sigma bond, this pi bond is not parallel. This pi bond is perpendicular. Clear? Or else pure p orbital is perpendicular to the sigma bond, or pure p orbital or pi bond, you can say pi bond. Clear? If you remember this point, if you remember this key point, now whatever may be the question they may ask about the benzene, you will never and ever you will make the mistake. Only this is the one key point you have to remember. What? Benzene pi bond is perpendicular to the sigma bonds. Perpendicular to the sigma bonds. Clear? Now this is about the benzene. This is about the benzene. Now let's comes to the which one? Just now I explained very clearly when it comes to the phenol. Now we know the phenol. In this phenol, it will show the plus M effect and it will show the minus I effect. But which effect is more dominating for the phenol? Plus M effect is more dominating for the phenol than the minus I. Why? Why only the plus M effect is more dominating than the minus I? Now listen. Mesomeric effect to show, what is the first condition we have? Mesomeric effect to show first key point, all 2p orbitals should be in plane, or parallel to each other, okay. This is the one key point we have to remember. Now based on this key point, how the phenol is showing the plus M effect is more than the minus I. Now with the molecular model I will explain. Now listen carefully. In the phenol, now you can see this is the phenol. Now in the phenol, here you can see in this phenol, now this carbon is 2p. Now this oxygen is also a 2p. Now oxygen contains 2 lone pair of electrons, right? Now this lone pair of electron only will be delocalized to the benzene ring and it will increase the electron density at ortho and the para positions. Now how this oxygen is giving its lone pair of electrons to the benzene? Now we'll see. Here now this pi bond or the pure p orbital which has formed the pi bond in the benzene is parallel to the sigma bond or perpendicular to the sigma bond, that is perpendicular to the sigma bond, right? Now you see here, now this pure p orbital, now you can see this pure p orbital, this oxygen lone pair of electron and this pure p orbital is also a parallel to each other, right? Delocalization to happen or mesomeric effect to happen. Now what? This lone pair of electron and this which one? Pure p orbitals should be parallel to each other. Now these two are the parallel to each other. Now that's the reason only this oxygen, its lone pair of electron will be given to the benzene very effectively. It will give to the benzene very effectively.